friends, welcome to my channel once again. In the previous videos, we understood that time and space are relative. What does that mean? That means that the gap between two events and 2 points are different for different observers. In this video, we are going to understand how mass is relative. So let's get back to our train on the graphical track, where we understood that space and time are relative. So first, getting into the details, let's first be clear about the relativity where it works. It works when the speed of a body is very large. How large it should be? It should be so large that it is approaching the speed of light, but it can neither equate to the speed of light nor it can overtake this limit. So at best it is approaching. It will always be less than but near to the speed of light. There our relativity, which was given by Albert Einstein, works the best. So let's understand what is this relativity of mass all about. Well, so let's say that the mass of the train is m0 at the rest, right? So according to the Einstein's formula, E equal to mc square, that is the mass energy equivalence, very popular and famous equation. So from there we understand that E0, the equivalent energy, will be E0, which is equal to m0 c square. Now let's say our train is moving at a very high speed, which is approaching to the speed of light, v. So at that speed we have a different mass that will be given as mv, not m0, and this is all about the relativity of mass, right? So mass is varying, it is not a fixed. So at that mass we have a different energy, it will be ev. So according to the same equation, E equal to mc square, we have ev equal to mv c square. Now what is this, the relation between mv and m0? This relationship is given by this formula from the relativity. This factor we have already seen in the previous video, right? Okay, first let's understand the concept, what is happening there before getting into the equations. So mass, as we have seen in a different video where we have defined the definition, so we understood mass as the inertia, that is, it resists the applied force upon it. Now we understand that to get a body at certain speed, we have to do certain amount of work, which is possessed as a kinetic energy by the body. So to place a body at a higher speed, we require to do more amount of work that will be stored as a higher kinetic energy by the body, and the formula for kinetic energy you all know is the half mv square, right? So far so good, but what is the point here about the relativity? The point is this resistance to the force applied means you have to do work, that means you have to apply a force. So the relativity puts a limitation that body cannot cross this limit, not cross, even it cannot touch the speed of light. So from here we understand that there is an inherent resistance from the body that it does not want to approach the speed of light, so that you have to apply a large amount of force and you have to do a large amount of work, right? So the energy should become so high, right? It should be approaching infinite amount of energy, infinite amount of work done, that it is getting impossible to approach the speed of light. And how this high amount, which is infinite amount of energy or work or force, by the resistance, which is the mass. Basically, if your mass is increasing very high as you are approaching to the speed of light, what will happen is the resistance to the force is getting higher, so you require more amount of work to be done, right? So more amount of work to be done means you have to give an infinite amount of energy. Now, having understood this concept, now we know why this mass is being relative at such a high speed, right? Now let's see how the equations are giving the same result which we have just understood the concept. So at the rest, the equivalent energy is this. At the speed of v, the equivalent energy is this, right? If we find out the difference between these two energies, means how much more energy it got, right? So difference will be this, c square will be common, right? So let's assume for a time being that this expression is correct. Which expression? This expression is correct. So we can put for mv this thing, and again m naught will become common. You can take out m naught, and this factor in the denominator, it has root. So if you take in the numerator, the power becomes minus half. Now you can apply this formula. This is going to the infinite terms, right? But let's take these many terms. So we have this expression. If we apply this expression here, what we get is, we get this result, right? Now let's understand what this result is. You can see this term. This is half m naught v square. Our kinetic energy is half mv square. Let's understand how we are getting. If we take our speed of a train is very less in comparison to the speed of light, then what happens is this term and further terms, right? It is going to infinite terms. The further terms, including this one, becomes almost zero, right? So we are left with this. So now do you understand? If we are giving a speed of v, how we are getting half mv square from this term also? So obviously this factor, right, must be true, because this is giving us the half mv square formula for the kinetic energy, right? But this is the half story. What is the full story? Full story is, but let's say our speed of the train is not less or very less than the speed of light. Let's say it is approaching to the speed of light, right? Not equal or more, it is less than, but approaching near to the speed of light. Then what will happen? Can you ignore this factor or the further factors? Let's limit ourselves to this factor only, right? So what we see is, now you can't ignore this factor. That means the energy possessed by the train is not just simply half mv square. It is a too big energy. Now how to give this large amount of energy, right? So from here we understand that how this relativity of mass is working. Why this is working? Because to place a body near to or approaching to the speed of light, the requirement of the energy is too high, it is almost going to be infinite. If we take further terms, if we consider, right, it's becoming too large, almost infinite, and that is not practical. So this is inherently put by the body itself, that it does not want to approach to the speed of light, and mass being the inertial property of a body, it is resisting this. I hope you understood this concept, how mass is relative, right? So thank you for watching this. If you like my video, if you feel that the videos are interesting and informative, please do subscribe my channel, like it, subscribe it, and share with others, and do watch my all videos. Thank you once again.